Okay, now we got y equals to tan x, and tan x is sin x over cos x. Yep, that's the formula. We need to use the quotient rule to actually differentiate this bit. Now, let's have a look at this one. So, if this is the question, first we need to identify the u and the v. So, let's say u is a sin x, and v is the cos x. Okay. Now I need to differentiate the sin x. Now differential of the sin x, du over a dx. Differential of the sin x according to the formula, according to the differential of the trig, is cos x. But differential of this cos x, so I need to differentiate the v. dv over dx. Differentiation of this one is actually a sin x. Actually minus sin x. So we have that. Now I have the formula, quotient rule formula. I will put everything in that quotient rule formula to get an answer. So let's put that bit in the quotient rule formula and we see what we get. Okay. Now according to the formula, let me do the formula on this side. According to the formula, I got v, which is cos x, times by du over dx. du over dx is another cos x. Then there is a minus of the formula, this minus. Then u is here, which is a sin x. U is a sin x, and then dv over dx. dv over dx is another minus sin x. So that's minus, that minus should be in the bracket. Minus sin x. And the bottom is v square. What is v square? V is cos x. So square of the cos x. Cos square x. Yeah, that's how we write the cos square x. Yeah, we got that. Now, we need to simplify. The cos x times cos x becomes a cos square x. And the sin x times sin x becomes a sin square x. Now this is a minus and a minus. The two minuses makes a plus. And the bottom is just a cos square x. Now there is a trig identity. You need to remember the trig identity. You can check in your calculator as well. Always remember cos square x plus a sin square x is how much? Anyone knows? 1. It's a 1. Yeah. So cos square x plus sin square x is a 1. So the top thing becomes a 1. So I got 1 over cos square x. And you know what's 1 over cos? 1 over cos is actually secant x. Yeah. Because there's a square, so I need to put a square. So this is my dy over dx. If you want to differentiate d over dx of the tan x, it is secant square x. Yeah. So this is our answer.
Recording in progress.
Okay, let's say I got the first question. Let me do that one. Actually, let me do the second one. Question number 2. Let's say I got y equals to cos x over x squared. Now we have to use the quotient rule in that one. We need to distinguish which one is u, which one is v. So let's say the u is a cos x, and you know the differential of the cos x is a minus sin x. So if I do du over dx, this is going to be minus sin x. Now then we got the v. The v is always the denominator. So v is how much? X squared. So if I do dv over dx, dv over dx, that's the differential of this is just 2x. Now I will follow my rule. I will follow this quotient rule and I will just put the value. According to the quotient rule, if I want to find dy over dx, I need to put the v square. V square is x squared, so I need to do the x square. Then I need to do the square of that because v is that one. Now then I got the v here, which is just an x square. And then du over dx. Du over dx is actually a cos x. This cos x comes here. Then there's a minus of the formula. Then there's a u. No, sorry. Du over dx is the sine x. It's not the cos x. It's the sine x or minus sine x. Yeah. So it's the minus sine x. That thing becomes the x4, the bottom bit. Okay, that thing, x squared, then minus sine x. We solve that one later. All right, du, yeah, that's right. D is this. Now I need u. U is cos x. That u is cos x. And then dv over dx. dv over dx is just a 2x. Okay, now I need to simplify that one. This is x squared and minus sine x. They are multiplying. So that will become minus x squared sine x. And then we got the cos x dot 2x. So minus, usually we write 2x here. 2x cos x. Yeah. Now you can further simplify it. If you have a look, there's an x here and there's an x here. So if I take x common, just an x common, I'm left with minus x sine x. Obviously, you cannot take this x common. It has to. It was x squared, but I've taken one x out. So that becomes just the x here. Minus 2 cos x. Because this x I've taken outside from here. So this x is now multiplying. If you multiply it, it becomes the x squared. If I multiply here, it becomes a 2x. Yeah? Divided by x to the power 4. X to the power 4, I can write that one as x to the cube dot x to the 1. Yeah? I can do that one. I can break it out. This x and this x will cancel out. So my answer will be minus x sine x minus 2 cos x over x cubed. That will be my answer. You cannot simplify it further. Okay, question number 6. Now this is a quotient rule. You have to just identify the u and the v. So the u is e to the minus 3x. And if I want to find the du over dx, differential of that one, derivation of this one, it's going to be e to the minus 3x. It's exactly the same. Plus you need to differentiate the top bit. So when you differentiate the top bit, differential of minus 3x is just a minus 3. Yeah. So I got du over dx done. Now v. My v is x squared plus 1. So if I want to find the differentiation of this one, this is going to be 2x plus 0. So I got 2x. Now I need to apply the quotient rule, which is here, and I need to fill that one in. So Phil put the values. So differential of that one is v squared. V is just the bottom bit, which is x squared plus 1, and I need to square that one. And I need to put a minus here. And then v here, v is x squared plus 1. And then I need to do is du over dx. Du over dx is minus 3 e to the minus 3x. Okay. Now u minus u. U is e to the minus 3x. This is x. And then dv over dx. dv over dx is just a 2x. Bracket 2x. Now I need to simplify this bit. The bottom is just an x squared plus 1 squared. When I do that one, it's better to write this red bit in the front. Minus 3 e to the minus 3x. And then you got this black x squared plus 1. And then minus, here you got 2x. And then the black one, e to the minus 3x. Okay, this is your dy over dx. You can do one more step to simplify, and that will look like this, because you have if you see e to the minus 3x and e to the minus 3x, they are common here. So you can take e to the minus 3x common. And then what's left? If I take that one common, I got minus 3, this minus 3 as it is, and this x squared plus 1, and then minus, and then 2 is still there, 2 is still there, and x is still there, and this e to the 3x come out. Yep, so that's that. The numerator remains the same. You can further simplify it. Multiply the 3 inside. So minus 3 times x is minus 3x squared. Minus 3 times 1 is minus 3. And then minus 2x. And that is your differentiation of this one. Derivative of this bit is that. Okay, that's your answer. Okay, let's have a look at the question number 8. Y equals to 2x plus 1 divided by x squared minus 3. So let's identify the u and the v. So the u is the 2x plus 1. And I need to find that du, differentiate this thing, du over dx. And you know du over dx of 2x plus 1 is just a 2. Now I got the v. The v is x squared minus 3. Now I need to differentiate this with dv over dx. Differentiation of the 3 is a 0, so I ignore that constant. Differentiation of x squared is just a 2x. Now I need to do is I need to get this product quotient rule. So dy over dx is equal to, what's the v? V is x squared minus 3, so I need to square that one. X squared minus 3, and then I need to square that one. And then I need to put the v here. X squared minus 3. And then I got the du over dx. du over dx is just a 2. So I can put the 2 here. And then there is a minus of the formula. Then I got the u. The u is just a 2x plus 1. And then I got dv over dx. Now dv over dx is just a 2x from here. Now I need to simplify that bit, draw a big line. Now the bottom remains the same, x squared minus 3n squared. Now this 2 is multiplied. So x squared times 2 is 2x squared. Minus 3 times 2 is minus 6. And then I got this minus here. Okay, just keep that minus here. I still keep the bracket, but I change that shape. 2x times 2x is actually the 4x squared. 1 times the 2x is plus 2x. Now I need to open this minus because there's a negative here, which was that negative was here. I need to open this negative sign, multiply that negative inside. If you open this bracket up, this negative will change all the sign inside. This is a positive, that becomes a negative 4x squared. This is negative and positive, that becomes a negative 2x. The bottom remain exactly the same. Now we can see what we can do with that bit. I got 2x minus 4x. So 2x minus 4x is actually a minus 2x squared. 2x squared minus 4x squared is minus 2x squared. Then I got this minus 6. Then I got minus 2x. They are on their own. So I can write it this way. And this is your dy over dx. And that is your answer for question number 8 in a simplified form.